f is an onto function, therefore f is an invertible function. So let us consider a function let f of x is equal to y, where x belongs to r minus 3, that's equal to a. Suppose if a is an identity element which belongs to a, if it exists, is called an identity element. If a star b belongs to a, then star is a binary operation. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class, we have discussed regarding the revision of relation and function. In that session, we have discussed regarding different types of functions as well as the problems based on invertible function. Now, in this session, I am going to take few more problems on invertible function as well as the very important concept, that is binary operation. Now let us come to the first problem on invertible function. This is very important type problem. You may expect this question for your 2022 examination for 5 marks. So usually this year you are going to get 2 5 marks questions like this. So let f from n to r be the function defined by f of x is equal to 4x square plus 12x plus 15. Show that f from n to s, where s is the range of f, is invertible. Find the inverse of f. Now we have to verify whether the given function is invertible. If so, then find the inverse. Now to verify whether the given function is invertible, it should be 1, 1 and onto. That is a bijective function. To verify this as a bijective function, we have to verify whether it is 1, 1 and onto or not. Now let us check whether it is 1, 1 or not. Let, what is given? Given f of x is equal to 4x square plus 12x plus 15. Now let us consider f of x1. f of x1 is equal to, this is 4x1 square plus 12x1 plus 15, and f of x2 can be written as 4x2 square plus 12x2 plus 15. Let f of x1 is equal to, let f of x1 is equal to f of x2. Now just substitute the value of x1. What is f of x1? 4x1 square plus 12x1 plus 15 is equal to 4x2 square plus 12x2 plus 15. Simplify this. Let us bring this to the left hand side. 4x1 square plus 12x1 plus 15 minus 4x2 square minus 12x2 minus 15 is equal to 0. This 15 and 15 gets cancelled. 4x1 square minus 4x2 square is one group, plus 12x1 minus 12x2 is another group. Now this can also be written as, you can take 4 common factor, x1 square minus x2 square, plus this is 12 common factor, 12 into x1 minus x2 is equal to 0. Now since this can be written as x1 plus x2 into x1 minus x2, because this is of the form a square minus b square is a plus b into a minus b. So plus 12 into x1 minus x2 is equal to 0. Now in this 2 you can take x1 minus x2 as common factor, x1 minus x2 out. What is left over is, outside the term we have 4 into x plus x1 plus x2 plus 12 is equal to 0. So x1 minus x2 is equal to 0, whereas 4 into x1 plus x2 plus 12, this is not equal to 0. Right. Now therefore if x1 minus x2 is equal to 0, implies x1 is equal to x2. So therefore what do you say? F of x1 is equal to f of x2 implies x1 is equal to x2. Therefore f of x is 1, 1 function. F of x is 1, 1 function. This is how we are going to verify 1, 1 function. Or you can also verify by Fogg and Goff method also. Okay. Now this is the first part. Now to prove the second part, what is to prove? To verify whether f of x is onto or not. Now let us come to the second part. Now for the function f from n to s, s is the range of f, that is given, s is the range of f. So now let us come to the second part. To prove that f of x is onto function. To prove that f of x is onto, what is given? For the function, given for the function f from n to s, for the function f from n to s. Now, what is given? Given, see the given, s is the range of f. This is the given condition. Given that codomain of f is equal to range of f. This is given. So, what is given here? So, for the function f from n to s, given that the codomain of f is equal to range of f, that is nothing but s. That is given condition. Okay. So, therefore, f is on to function. Therefore, f is on to function. Therefore, f is invertible. Therefore, f is invertible. F is invertible and f inverse exists. That's it. This is the second part. So, very simple. The second part is for the function f from n to s, given that the codomain of f is equal to range of the function range of f, that is equal to s. Therefore, f is an onto function. Therefore, f is an invertible function. Now, find out the inverse. What is given here? S is the range of f is invertible. Find the inverse of f. If it is invertible, find f inverse. Now, to find f inverse, let us consider, let y be an arbitrary element of s. Let y be an arbitrary element of s. Therefore, the given equation, what is the given equation? 4x square plus 12x plus 15 is equal to y. Y be an arbitrary element of s. Therefore, 4x square plus 12x plus 15 is equal to y for some x belongs to n. Okay. Now, simplify this using the completing square, you will get the answer. It can be written as 2x whole square plus 12x can be written as 2 into 2x into 3 plus this 15 can be written as 9 plus 6 is equal to y. Now, this entire quantity can be written as, this is of the power of a plus b whole square, 2x plus 3 whole square plus 6 is equal to y. See here, a square plus b square plus 2ab, 2 into 3x into 6. So, using completing the square, we can solve this like this. So, 2x plus 3 whole square plus 6 is equal to y, or only 2x plus 3 whole square can be written as y minus 6, or 2x plus 3 is equal to root of y minus 6, or 2x is equal to square root of y minus 6 minus 3, and x is equal to root of y minus 6 minus 3 divided by 2. Okay. Now, let me go to the next page. What is therefore x is equal to, what we got, x is equal to root of y minus 6 minus 3 divided by 2. Now, let us define g from s to n by this y minus 6 under root minus 3 divided by 2. Now, I will go to the next page. Now, define a function g from s to n by g of y is equal to root of y minus 6 minus 3 divided by 2. That is what we got from the previous step. So, let us define a function s from n to n by g of y is equal to root of y minus 6 minus 3 divided by 2. Now, write down g naught f of x. Now, therefore, g naught f of x can be written as g of f of x. So, this is equal to g of f of x. What is f of x? The given equation, that is, given equation is 4x square plus 12x plus 15. So, this can be written as, this is nothing but g of 2x plus 3 whole square plus 6, right. So, this is equal to, so this can be written as square root of, so substitute this, that's it, 2x plus 3 whole square minus 6, 2x plus 3 whole square plus 6 minus 6 minus 3 divided by 2. So, this is equal to, this square and square root gets cancelled. What is left in the numerator is 2x plus 3 minus 3 divided by 2. Minus 3 plus 3 gets cancelled. 2x by 2 is equal to x. Okay. And similarly, f naught y, f naught g of y is equal to f of g of y. So that is equal to f of this root of what is y? Root of y minus 6 minus 3 divided by 2. Now substitute this here in this equation. So therefore f of y can be written as 4 into root of y minus 6 minus 3 divided by 2 whole square plus 12 into root of y minus 6 minus 3 divided by 2 plus 15. Now let me simplify this. So 4 into y minus 6 under root minus 3 by 2 whole square plus 12 into this 2 to gets cancelled. So simplify this. What is the answer we are going to get? I will simplify it. 4 into square root gets cancelled. Y minus 6 a square plus b square 3 square is 9 minus 2ab 2 into 3 is 6 into root of y minus 6 divided by 2 square is 4 plus this 2 6 gets cancelled. 6 into root of y minus 6 minus 3 plus 15. Simplify this. So here 4 and 4 gets cancelled. What is left over is y minus 6 plus 9 minus 6 into root of y minus 6 plus 6 into root of y minus 6 minus 6 into 3 18 plus 15. So minus and plus gets cancelled, and what is left over is y. 9 minus 6 is plus 3, y plus 3, and what is left here is minus 18 plus 15 is minus 3. So minus 3 plus 3 gets cancelled. This is equal to y. Okay, f of x is equal to y, that is g of y is equal to y. So from this we can conclude that therefore g naught f is equal to I and f naught g is also equal to I. Identity. So what do you say? Therefore f inverse is equal to g. F inverse is equal to g. That's it. From this we can say g naught f is equal to I and f naught g is equal to I. Therefore f inverse is equal to g. F inverse exists, that is equal to g. So therefore f inverse is equal to g means therefore f inverse is equal to root of y minus 6 minus 3 divided by 2. That's it. Okay. Now let us come to the next problem. If a is equal to r minus 3 other than 3 and b is equal to r minus 1 other than 1, consider the function f from a to b is defined by f of x is equal to x minus 2 by x minus 3 if f is on 1 1 and on 2. We have to verify whether f is 1 1 and on 2 function. What is defined? F from a to the function defined from f from a to b is given by f from a to b is defined by given by f of x is equal to x minus 2 divided by x minus 3. So the function f from a to b is defined as f of x is equal to x minus 2 divided by x minus 3. Just verify whether it is 1 1 or 2. Let x1 comma x2 belongs to belongs to a. Now let f of x1 is equal to f of x2 implies what is f of x1? X1 minus 2 by x1 minus 3 is equal to x2 minus 2 divided by x2 minus 3. Simplify this. X1 minus 2 into x2 minus 3 is equal to x2 minus 2 into x1 minus 3. So this can also be written as multiplied x1 into x2 is x1 x2 minus 3 x1. Again minus 2 into x1 is minus 2 x2. Minus into minus plus 3 2s are 6 is equal to x1 x2 minus 2 x1. Again minus 3 into x2 is 3 x2. Minus into minus plus 3 2s are 6. Bring this to the left hand side. X1 x2 minus 3 x1 minus 2 x2 plus 6 minus x1 x2 plus 2 x1 plus 3 x2 minus 6 is equal to 0. So here plus x1 minus x1 x2 gets cancelled, then plus 6 and minus 6 gets cancelled. What is left over is minus 3 x1 and plus 2 x1, then minus 2 x2 plus 3x2 is equal to 0. Simplify. Minus 3 plus 2 is minus x1. Plus 3 minus 2 is plus x2 is equal to 0. X1 is equal to x2. Just transfer this to the left hand side. X1 is equal to x2. That means f of x1 is equal to f of x2 implies x1 is equal to x2. Therefore, f of x is 1, 1 function. That's it. The first part is finished. F of x is 1, 1. Now, let us go for onto function. Now, to verify onto function, let us consider f of x is equal to y. Now, to prove that f of x is onto. Now, to prove that f of x is onto, let us consider a function like f of x is equal to y. And what is the given condition? Where x belongs to r minus 3. X belongs to r minus 3. That's equal to a. That is given. So, let us consider a function like f of x is equal to y, where x belongs to r minus 3. That's equal to a. Right. Now, what is f of x? Substitute the value of f of x. F of x is x minus 2 by x minus 3 is equal to y. Cross multiply it and simplify it. X minus 2 is equal to y into x minus 3, or x minus 2 is equal to xy minus 3y. Okay. Now, transfer this. X minus xy is equal to, and minus 2 becomes plus 2. 2 minus 3y. You can take x common factor. 1 minus y is equal to 2 minus 3y. So, therefore, x is equal to 2 minus 3y divided by 1 minus y. So, this implies 1 minus y is not equal to 0. So, this implies y is not equal to 1. That is other than 1. So, which implies range of f of x is equal to range of f of x. The range of f of x is b. That is, the range of f of x is r minus 1. That is nothing but b. That is given. So, that means the range of f of x is equal to codomain, which implies range of f of x is equal to codomain. So, see here, since x is equal to 2 minus 3y by 1 minus y, which implies 1 minus y is not equal to 0, that means y is not equal to 1. So, therefore, the range of f of x is r minus 1 other than 1, which is nothing but b. That means the range of f of x is equal to codomain. So, what do you say? Therefore, f of x is onto function. Therefore, f of x is onto. That's it. So, that means f of x is both 1, 1 and onto. It is a bijective function. That is to be verified. That's it. What is to prove? We have to prove whether f of x is 1, 1 and onto. So, f of x is onto. That's it. This is how we are going to solve the problem. So, these are few types of problems on a invertible problems. Hope you followed. So, you practice this type of problems, definitely you will get 2 questions from this type of problems. Now, let us come to the next concept. Next, come to the binary operation. Let us know what is a binary operation. Binary means 2, operating on any 2 elements of the set. So, here define, how to define a binary operation is usually denoted as star. Suppose a binary operation star on a set A. A binary operation star on a set A is a function from star to A cross A. A function star such that A cross A to A is denoted as star of A comma B by A star B is called a binary operation for all A, B belongs to A. That is, star, the binary operation, it's a function on a set A is a function star from A cross A to A. A function star from A cross A to A, and it is denoted as, this is denoted as star of A cross B. A cross B by A star B is called the binary operation. If A star B belongs to A, then star is the binary operation. Now, let us consider a small example. On the set of natural numbers n is equal to 1, 2, 3, 4, addition is a binary operation. A star B is defined as A plus B for all A, B belongs to n is a binary operation. That means addition is a binary operation, because if you add 1 plus 2, you will get 3, 2 plus 3 is equal to 5. That is also included in the set. Whereas if you subtract on the set of natural number, 1 minus 2 does not belongs to n, therefore it is not a binary operation. Now, let us come to a simple problem. Usually they may ask this type of questions. Show that star from R to R is given by a comma b is equal to a plus 4b square is a binary operation. Now, let us come to the first problem. These are all one more question. Show that star from R to R is given by a comma b is equal to a plus 4b square is a binary operation. Since a and b belongs to R, so therefore a star b is equal to a plus 4b square also belongs to R. So therefore star is a binary operation. Star is a binary operation on R. So if you want, you can take any element. Let us take a is equal to 1 and b is equal to 2 belongs to R. So 1 star 2 can be written as 1 plus 4 into 2 square. So 2 square, that is nothing but 1 plus 4 into 2 square is 4. 4 4s are 16. 1 plus 16, that's equal to 17 belongs to R. So therefore star is a binary operation. Now let us come to the second one. Determine whether star given by a star b is equal to a minus b on z plus for all ab belongs to z plus is a binary operation or not. Directly you can see here a star b is equal to a minus b. So since a comma b belongs to z plus set of all positive integers, if we subtract a minus b does not belongs to z plus. A minus b does not belongs to z plus. Therefore, star is not a binary operation, is not a binary operation on this z plus. So, because say for example, if we take a is equal to 2 and b is equal to 5, then what is say a minus b? A minus b, that is a minus b can be written as 2 minus 5. 2 minus 5 is equal to minus 3. This does not belongs to z plus. This is not a positive integer, negative integer. So therefore star is not a binary operation. This is not a binary operation. Now let us take next problem. Whether star is given by a star b is equal to mod of a minus b on z plus for all ab belongs to z plus, it's a binary operation. Definitely this is a binary operation because modulus of negative is a positive number. So therefore since a comma b belongs to z plus, therefore mod of a minus b also belongs to z plus. Therefore star is a binary operation. If you want, you can take a is equal to 1 and b is equal to 2. 1 comma 2. 1 comma 2 is equal to 1 minus 2, that is equal to mod of minus 1 is equal to 1 belongs to z plus. Therefore star is a binary operation on z plus. Now let us come to this problem. These type of problems are very important. You may expect this type of problem for 1 mark. Now find star is the binary operation on n given by a star b is equal to LCM of a and b, least common multiplier of a and b. So therefore find 5 star 7 and 20 star 16. So 5 star 7 is nothing but LCM of 5 and 7. The LCM of 5 and 7 is, that is nothing but 5 into 7, that's equal to 35. So the LCM of 5 and 7 is 35. Let us come to the second problem. This is nothing but the LCM of 20 and 16. LCM of 20 and 16. So if you take the LCM of 20 and 16, 16 and 20, how does you take LCM? So you can write 4. 4 4s are 16, 4 5s are 20. That's it. So 4 into 4 into 5. 5 4s are 20. 20 into 4 is equal to 80. So the LCM of 20 and 60 is 80. That's it. Okay. So we can write therefore LCM of 20 and 16 is equal to 80. Here LCM of 5 and 17 is equal to 35. That's it. Now let us come to the next problem. Same. So you may expect this type of question. So if a star b is equal to LCM of a and b, then find a star LCM of 3 and 4. So LCM of 3 and 4 is equal to 12. Here the LCM of 4 and 8 is 4 and 8. Just take LCM. What is the LCM? 4 1s are 4 2s are, that's equal to 8. Similarly, the LCM of 12 and 16. 12 and 16 for 12 and 16. So 4 3s are 4 4s are. So that is nothing but 4 into 3 into 2. 48. This is equal to 48. That's it. Okay. Now let us come to the next problem. Now if A is equal to 1, 2, 3, 4, 5, consider the binary operation cap on the set A defined by A cap B is equal to minimum of AB. Write the operation table of operation cap. We have to write the operation. What is given? A cap B is given as minimum of A and B, minimum of first and second element. Now write down the table. That is what is given here. A cap B is nothing but minimum of A and B. What are the elements? 1, 2, 3, 4 and 5. Here it is 1, 2, 3, 4 and 5. Now, what is to write the minimum of A and B? Minimum of 1 and 1 is 1, minimum of 1 and 2 is 1, minimum of 1 and 3 is 1, minimum of 1 and 4 is 1, minimum of 1 and 5 is also 1. 2 and 1 is 1, 2 and 2 is 2, 2 and 3 is 2, 2 and 4 is 2, 2 and 5 is also 2. The minimum of this, minimum of 3 and 4 is 1, 3 and 2 is 2, 3 and 3 is 3, minimum of 3 and 4 is 3 and minimum of 3 and 5 is 3. Similarly, minimum of 4 and 1 is 1, 4 and 2 is 2, 4 and 3 is 3, 4 and 4 is 4, 4 and 5 is 4. Similarly, minimum of 5 and 1 is 1, 5 and 2 is 2, 5 and 3 is 3, 5 and 4 is 4, 5 and 5 is 5. This is how we are going to construct the table for minimum. Similarly, for maximum. Okay, right. Now let us come to the next problem. That is laws of binary operation. So there are different laws. So the first one is the commutative law, associative law. Commutative and associative are the very important laws here. We are going to study commutative law. Now let us know regarding commutative law. So an operation star on a set A is said to be commutative if it satisfies commutative means if A star B is equal to B star A for all A B belongs to A. If for all A comma B belongs to the set A, if A star B is equal to B star A, then star is called a commutative. Commutative property holds good. Now similarly associative. What is associative property? An operation star on a set A is said to be associative if A star B star C is equal to A star B star C for all A B belongs to A. That is, if for all A comma B comma C belongs to the set A, if A star B star C is equal to A star B star C, A star B star C, then star is said to be associative. That is, A star B star C is equal to A star B star C. This is called associative. Now, let us come to the next problem. This is very important problem for 2 marks. So, this is very important problem. Determine whether star is commutative and associative on Q defined by A star B is equal to AB by 2 for all AB belongs to Q. Q the set of rational numbers. What is given? First verify whether it is commutative or not. So, commutative property. What is A star B is equal to AB by 2 for all A comma B belongs to Q. Now, what is commutative property? A star B is equal to B star A. If A star B is equal to AB by 2, then B star A can also be written as BA by 2. AB by 2 is equal to BA by 2. So, therefore, star is commutative. Star is commutative on Q. That's it. Star is commutative. Now, to verify associative property, second one, associative law. So, to associative property, what is associative property? For all A comma B comma C belongs to Q, A star B star C is equal to A star B star C. Now, let us write A star. What is A star B? See, A star B is equal to AB by 2 means B star C can be written as BC by 2. A star B is equal to AB by 2 star C. Now, since if A star B is equal to AB by 2 means A star BC can also be written as ABC divided by 4 is equal to ABC by 4. Therefore, star is associative. That's it. See here, A star B star C is BC by 2, A star B is AB by 2 star C. If A star BC by 2 can also be written as ABC by 2 into 2 is 4, AB by 2 into star can also be written as ABC by 4. So, therefore, this is an associative. Now, let us come to the next one, same type. So, determine whether star is commutative and associative on Q defined by A star B is equal to AB by 3 for all AB belongs to Q. Same type problem. Now, since for all A comma B belongs to Q, A star B is equal to AB by 3. So, commutative property means what is commutative? Commutative law is A star B is equal to B star A. That is A star B is AB by 3 is equal to BA by 3. So, therefore, star is commutative. A star B is equal to AB by 3 means B star A is equal to BA by 3. Therefore, star is commutative. Now, to prove the second one, associative. For all A comma B comma C belongs to Q, what is the property? A star B star C is equal to A star B star C. Now, what is A star B? A star B is equal to AB by 3. AB by 3 star C is equal to A star. What is BC by B star C? That is also equal to BC by 3. So, if A star B is equal to AB by 3 means AB by 3 star C can also be written as ABC divided by 3 into 3 is 9. This is also equal to ABC by 9. So, therefore, star is associative. Associative on Q. That's it. So, if you do this much, you will get 2 marks. Very simple. Now, let us come to the next property. Third one is identity property. That is identity property, existence of identity element. Given a binary operation star from A cross A to A with the identity element E belongs to A. Suppose if A is an identity element which belongs to A, if it exists is called an identity element. That is element on the operation star. If A star is equal to E star, A is equal to A, any element into identity element is equal to same element, then we can say that E is the identity element of A for all A belongs to A. So, that is if for all A belongs to A, there exists an element E belongs to A such that A star E is equal to A or E star A is also equal to A. A star E is equal to A or E star A is equal to A, then E is called the identity element of A. Okay. Now, after knowing identity element, let us know regarding the existence of an inverse element. Existence of inverse element. Given a binary operation star from A cross A to A with an identity element in A and A belongs to A is said to be invertible if the operation star is A star A inverse is equal to A inverse of A is equal to E. That means A, this is called the inverse of A and E is called the identity element. That is, if for all A belongs to the set A and E belongs to A, there exists A inverse belongs to A such that A star A inverse is equal to A inverse star A is equal to E, then this is called the inverse of A. This is the inverse of A. Okay, inverse A inverse denoted like this. Okay, now let us come to the final problem in this. Now, if A star B is equal to AB by 4, for all AB belongs to Q, find the identity element, inverse element, if exists, and also find 2 inverse and 3 inverse. Okay. Now, let us verify whether the identity element exists or not. Find the identity and inverse element. Now, first one, what is given? For all A comma B belongs to Q, A star B is equal to AB by 4. Now, what is identity property? Identity law. identity property. So what is identity law? For all A belongs to Q, there exists E belongs to Q such that A star E is equal to A. A into identity element is equal to A. Now, since A star B is equal to AB by 4, therefore A star E can be as AE by 4 is equal to A. Cross multiplied, AE is equal to 4A. AA gets cancelled, E is equal to 4 belongs to Q. This is the identity element. So, therefore, the identity element is E is equal to 4 is the identity element. E is equal to 4 is the identity element. Now, after finding the identity element, find out the inverse. Inverse. What is inverse property? So, the second one, inverse property. What is inverse law? For all A belongs to the set capital E, A belongs to Q, there exists A inverse belongs to Q such that A star A inverse is equal to E, where E is the identity element and identity element what we obtained is 4, since E is equal to 4. What is A star A inverse? Since A star B is equal to AB by 4, A inverse, A star A inverse is equal to E can be written as A inverse by 4 is equal to E. Now, since what is E? E is equal to 4, A inverse by 4 is equal to 4. Simplify this. A inverse is equal to 4 into 4, that's equal to 16. A inverse is equal to 16 in the sense A inverse is equal to 16 by A belongs to Q. So, therefore, A inverse is equal to 16 by A. Further, what is required to find 2 inverse and 3 inverse? To find 2 inverse and 3 inverse. What is given? What is we obtained? What is A inverse? A inverse is equal to 16 by A. So, 2 inverse is equal to 16 by 2, that's equal to 8. And 3 inverse is equal to 16 by 3. That's it. These are the inverse of 2 and 3. That's it. So, the inverse of 2 is 16 by 2 is 8 and inverse of 3 is 16 by 3. So, if it is divisible, divide it, otherwise just skip. So, this is how we are going to find. So, in binary operation, you may expect one question for 2 marks and one more question for 3 marks. So, the problems based on associative property, commutative property, existence of identity and inverse and the binary operation. That's it. So, that's all regarding today's session. So, hope you followed this. Just practice all these type of questions. These type of questions are very useful for your examination. Now, let us meet with the different concept in the next class. Thank you very much.